Hello guys, welcome to another episode of Cuda Education. So today I want to make a very short video about a small piece of the pie as we continue to move along in the process. So in Clean Slate 2.0, we sort of went over the steps for rendering the bistro scene. Now, this bistro scene, we talked about kind of the full step to get to this part right here, which is basically rendering part of the scene. The camera doesn't move. I can't move around the camera. Obviously, the textures and the full workup of the scene isn't there yet, but it is much better than a simple triangle. Remember, in our previous episodes, we had an orange triangle with three vertices and a very simple thing. Now we're getting something a little bit more involved, a little bit more special. We're starting to see something called of a bistro scene, right? Still a lot of work to do, but we went over all of these steps that was outlined here just quickly, right, in the previous episode. Now what we want to do is continue that process and just dive into each one of these steps. Now the first step was sort of, to review the AAPLSimple.metal file, AAPLSimple.metal file, which is this file right here, and these were the things added, okay? Now, if we go back to our this previous discussion, we did, render the bistro, all the things that we did, but then we talked about the AAPL simple.metal file, right? Which is this guy, which is what we'll discuss. Now, you guys know when you see .metal, you know that it means it's a shader, which means that it's GPU side code. It's instructions for the GPU. The GPU is running these instructions, right? So .metal means shader means GPU side code. You also notice that you have this M logo here, which kind of tells you that we are running metal, and metal is basically concerned with the GPU. In our case, it's Apple Silicon, where it's the CPU and GPU is sort of fused together, but obviously there is still, you could target the GPU and all that stuff. Okay, so in this APL simple .metal shader file, we we added a new vertex shader, we added a new fragment shader, and we added in two new structures. So mesh vertex in with attribute 0, position float 3, and attribute 1 with a normal. And then mesh vertex out with position, clip position, and float normal 3. Okay, so these were the two structures that we added into this APLSimple.metal file. And then the new vertex shader and the fragment shader uses it. Now the vertex shader, of course, is dealing with vertices. So just like with our triangle, a triangle has three vertices, right? And we use the vertices to construct your objects and things of that nature, your whatever it is you're trying to render, right? It's made of vertices. So that's the vertex shader. The fragment shader is dealing with color. So in our triangle, we had an orange triangle, so the fragment shader dealt with the orange, okay? And here, as we could see, it's a lot more stuff going on, okay? But when where are we? For the vertex shader, it's mesh vertex in, stage in, and APL params buffer, transform position, view projection matrix, float 4 in position. So in position is, I guess, 3 items, and then we have to add a fourth item, because remember, float 4 is expecting four parameters, 4 vertices, 4 indices, however you want to call it. So we have 3 here, and then we just add this extra one for the fourth, and then passes normal through. So that's vertex related stuff. Fragment related stuff, now we have mesh vertex out, map the normal -1 to 1, -1 1 to 0 1, normal returns float 4 color, okay? And keep existing simple shaders, vertex simple shader, fragment simple shader for potential future use, right? So that's all we're trying to tackle in this episode, okay? We're just trying to figure out what's going on and what have you. Now, when we look at the actual file, AAPL we could see that we have, you see how you have the M file here, the M logo here? That means it's a shader file, it's a .metal file. All the other files is like .h or .m or .mm, you know, all that stuff, right? But we have our APL simple shader file, and that's this guy right here. And then of course, this is where we add in all the things that we discussed before. Now you guys should know by now that fragment shaders, fragment again is dealing with color, right? And when we run our file the way it is right now, we get this, okay? But what I'm going to do is I'm going to mess around with the return value. So I'm just going to return 0, right? I'm not going to return float for color and 1.of. I'm just going to return 0. I'm going to rerun the file. And then you're going to see that we have the color disappears, okay? And that makes sense because a fragment shader is now not returning color. Now, obviously, if I undo everything and I rerun this thing, we're going to get our color back, okay? So here we have our color back, okay? So that's that for the fragment shader. I don't know if I did anything with this guy. I think because it's gonna complain if I don't return anything. So let's see. Replace. It might not even run. Yeah, it won't even run. I don't know. No? Is that a thing? Can I do that? No, can't do that. Okay. And then what if I just don't return anything? Yeah. Okay, so yeah, we can't do that for the vertex shader, right? But you guys get the drift, right? So we get back our thing, okay? All right, so let us dive into, again, this is the part of the code that was updated. Let's start with then update the renderer. So we're just dealing with AAPL Simple right now. So again, AAPL Simple, simple vertex and fragment shaders for basic geometry rendering, okay? So this is what, so we have our position, mesh vertex in position and normal, mesh vertex out, position, normal, right? Mesh vertex out, vertex mesh shader, mesh vertex in, stage in, and these are the params, and then we do some processing with it. So mesh vertex out is out, and then out position is camera params, view projection matrix times float for in position 0, right? And then out, return out. And then the color is just this normalize in times that plus that, and then we return out. I don't believe if I mess around with this that so right, if I mess around with this, notice that if I mess around with that last parameter, that I get, basically my scene disappears. So notice that the scene now, the position of the object moves away from where my camera is showing. So if I do 5, notice that it's all the way gone, right? If I do 0.5, right? I get this, okay, which is, let's do 8. So we could see that we have the ability to play around with this. All right, let's see. So we're basically at this branch right here, okay? So let's see if we get just a little bit more. All right, so we're moving further away. All right, so then if we do 0.2, yeah, you see, that's the thing. All right, so let's just put it back to 1. All right, so we're okay. All right, so we get the drift, guys. This is for this guy right here. All right. So this is AAPLSimple.metal. And we keep AAPL Simple Vertex out and Fragment Simple Shader. We keep these guys here, but we're doing the mesh shader rendering. Now it did say that we are going to keep existing simple shaders for potential future use, right? So maybe in the future we'll use that stuff, right? It's these things up here, but right now we're concerned with this stuff. And we saw that if we return 0 here, we don't get any color and all of that stuff. So that's all I have for today, guys. Thank you for watching. This is Cuda Education. You know what to do with the channel. Support the channel, and let's get it. I guess the next topic will be APL renderer, right? And notice that this is an M file, so I guess it's CPU side code, and that's what we have. Do I want to mess around with this normalize? Okay, normalize doesn't do anything. Okay. All right. Thank you guys for watching. Have a great day.